when it's ready for me. Okay, so as I graph this, watch. I'm going to put in x and y, and there's this t thing. So all you have to do for graphing parametric is it involves t, and for most of our purposes, we use parametric for things that involve time. So if I want to graph something, and I want to know at what time it hits certain x and y coordinate points, you can actually come up with an equation for it. So don't worry about where the equation comes from. Just say, all right, put in some times. So let's put in 0, 1, 2, and 3. I mean, really exciting times. Okay, so put that in there. Get that TI stupid view out of the way. And the x component is going to be whatever 4 plus t is. So that's where that comes from. And then the y component, of course, comes from -8 minus 5t. Simple enough, right? And then you plot the points. Sometimes it can you can decide how detailed you want it to be, because when I plot these points, it's going to be a pretty choppy looking graph. It's not going to be anything fancy. Put in 0 for time, and I get 4. Okay, because you see that 4 plus 0, which is 4. I'll write it out. 4 plus 0 equals 4. Okay, that's my x coordinate. And then y is going to come from -8 minus 5 times 0, which is just going to be -8. Okay, so ultimately, if you want to do your classic like xy table, what I just found out is one of my points is 4, -8. But what's cool about it is that I can also tell you, hey, what time did it hit that point? Well, time 0. That's where I started. So it's a little more detail. And so when you guys talk about becoming rocket scientists, which I know many of you are interested in such things, but if you become a rocket scientist, when you want to watch the flight of a rocket, it's not just about flying in space and where is it. You want to know when it gets to that spot and how. And that's ultimately most of the graphing of things in motion. We also want to know when does it hit a speed or a location. And that's what this is. It's called a parameter. You're giving it an x and a y location based on something like time. It could be based on other things, and this is just... So the key is you plug in inputs, and you get to choose these, or somebody tells you what t's to put in there. So it's not a... You can choose to make them more spread out. I can put in 0, and I can put in 0.5 and 0.75. You can put in whatever you want, but it's just going to graph more of the ultimate picture that you get out of this thing. So put in 1, and you get 4 plus 1 is 5. You put in 1 on this one, and -8 minus 5 is -13. If I mess up, you let me know. So we get 5 -13, but we know it happens at time 1. And then there's 2 goes in, and you get 6. And 2 goes in on the other one, and you get -5 minus 10, -18. And I could plot these points, which I will. And then 3 goes in, 7 comes out. 3 goes in, and -8 minus 15. This is where I'm going to mess up. It's going to be -8 minus 15, so -23, right? So 7, -23. If I plot this thing or graph it, I can give you a lot of room. I'll just make it real simple. Go up here, XY grid, over 4, down 8. Let's make this small, and then down -13, a little bit further, 18, 23. So what you get is it kind of looks like it's just descending down some hill. And one nice way to describe it is you could say, hey, this was at time 0. It was at this location, and at time 1, it was at this location, and so on. So it just tells you when you hit a certain spot, plots the same kind of stuff. It gets a little tedious, doesn't it? So what you can do, yes, activate your license. Sure. I don't know what my license number is. What? Come on. Why are you being so picky? Yes. All right, so we're not going to do that. We'll go to the big computer. Don't mind this. It'll have to be on your non-recorded screen. But if I go to your calculator, if you guys look up here, there's on the home screen, I'm sorry, it's called, what is that, mode? The mode button when you change degree and you do all that kind of stuff. Once upon a time, the only thing you ever changed was radian and degree, ever, right? I don't know if you've ever touched any of the others. Well, function, parametric, polar, and sequential, these are all the graphing methods that we actually explore in this class. I don't know if we'll do sequence, but we do it for Calc 2. Par, or par, means parametric. Some of your calculators write it out. But that is a mode that helps us graph what I just did. And it lets you do things a lot faster. So if you hit enter on parametric and you go to your y equals, it has an x space and a y space. So it's just there to aid you graphing it. It's really slick. So what do you put in x? You put in the 4 plus t that we were given. So 4 plus, and it's, if you hit, remember we used to hit x all the time? Xt theta. If you hit edit right now, it puts a t in there. It's cool. So if you notice under those buttons, it says xt theta n. Those are the variables that will spit out depending on what mode you're in. And since we're in parametric, it's the second one over, they're giving you a t. And then you put in your y equals negative 8 minus 5t. Negative 8 minus 5t. Done. Now, you can make tables all your life if you want to do this, but obviously that's going to get old really fast. So the thing about parametric is that you're going to have to tell it what t's and in what increments. And of course, the window about what's going to fit it is all part of it too. If you guys go zoom in standard, it'll probably give you an okay look at it. Maybe nothing, maybe a little piece. All of ours might be different because you might have different parameters plugged in. So we have to fix the window as soon as you graph it. So once you get the y equals set up, negative 4 plus t for x, negative 8 minus 5t for y, you hit maybe zoom 6 because that's what we always do. Now you got to go to the window and mess with it. Tmin and Tmax are new. And that's that t stuff I was telling you about. So didn't we graph 0 to 3, right? Something like that. So we did 0, 1, 2, 3. I can do that. I can type 0 for Tmin and 3 for Tmax. And then t-step is how far apart do you want your t-values to be. Choose as much as you like. The more detailed, the smaller they are, the more points it plots and the more detailed your graph, which is also kind of annoying. It takes a long time. Larger steps, it's going to look, the graph will look really weird if you take big gaps between your plotting. I mean, it might not even resemble itself. So don't let it be too big. If I put 1 in here, and then I hit graph, and you always hit graph after that because that's your adjusted, I'm not seeing much. And if you guys look at what we had before, it went all the way down to like negative 23. So my window is off. So you still have to have a sense of where your graph is. So I can't see how, like the minimum, which our table went to negative 23, so I'm going to put in negative 30 just to accommodate that. And then hit graph. So you still have to think. You have to plot. Hey, there it is. Now, that plot right there is connected lines. So what I showed you before on our picture, it was just the dots plotted, but what your calculator will do is connect them and make a graph of it and give you a piece of it. But that's all. It connects the dots and gives you a picture of it. How is that useful? Well, I can graph things like objects flying through the air and tell you when it hits a certain spot. And that's actually kind of slick. So that's what we'll end up doing. So when your mates come back, we'll do part B there to make that happen. There's this thing called refer to the graph of the parametric equations. Find the values that produce the graph in quadrant 1. Write your parameter values in the interval notation. Ah, it sounds scary, doesn't it? How can you imagine what that is? Well, you don't. You can use your calculator. You can do some graphing. So make sure you have a calculator. I haven't tried to plug this in yet. We're going to do x is t plus 4, and y is absolute value of t minus 1. Right. And I'm going to see if I can get a calculator on here. Why did I expire? Tell me why. What's wrong with my old license? Got a calculator. You're plugging them in. It's good to hear the giggles again. Math makes me giggle too. So we're going to plot this thing. If you want to do a table, you can. I might do a couple in the table. Well, here's quad 1, quad 2, quad 3, quad 4. Okay, we're going to graph this thing and see when it hits quad 1. So I'm actually going to delete those other quad things. I just wanted to give you the idea. 1, 2, 3, 4. You remember those. We want, when does the graph, the t values that produce the graph in quadrant 1. So think about this. I'm going to graph from negative 7 to 7, but I'm interested at what time does it land in said region here, the pink region. Ooh, that makes it more enticing, doesn't it? Okay. If you graph it and get a picture up there, I want you to guess. Just play around. Okay, so get your calculator up there. You put those in. I'll get mine up and running. So we go, x is t plus 4. see if you can, now trace will allow you to follow your graph. But it doesn't look detailed enough. And you and that person near you, try it together if you want. Do you remember how to get absolute value? Math num abs. Remember that? You go math num abs. Math nums your abs. Doesn't it? The first one. And then you type it in t minus 1. So nothing fancy. Cap. And zoom something. I'm just going to hit graph. Oh, well, that stinks. I can't see any of that. But your window is really important. That t min and max, did you know they gave it to you that -7 to 7 is what your t parameters are? So you go to -7. And you hit enter and you go 7 again. Step 1 is fine, but it's just going to plot a lot of separate points. We're going to put in something smaller. If you haven't done a smaller step, put 0.1 in there. Because then it'll go 7, 7.1, 7. It'll give you 10 points per second. You know, it kind of gives you a more descriptive picture. I don't need to go to -30, do I? Let's try -10. Let's just look at it first. Okay. Those are kind of some basics, like make your t, 0.1 is a good place to start. It's detailed enough. -7 to 7 is handed to us. I'm not making that up. And then if I hit graph with those new things plugged in there, hey, there you are, little thing. Now, it looks to me like, did you see that? If I graphed that, did you see how it was graphed from left to right? If you didn't, I'm gonna go in there and change this a little bit, make it 0.10. I think it'll regraph it for me. Watch, it graphs from left to right. Oh, didn't do it. Regraph. How about I change my X max a little? There we go. From the right to the left. That means from t equals 0, it started on the left and made its way over to the right. If you can't remember that, there is a table up above, like it always has been. Second and graph, there's a table. Go check that out. That's kind of a cool place to look. Hey, they have a t part. So it gives you a place to look at that. So you can put -7, hit enter. It starts at -3.8. And if you kind of want to see where the t is, so you don't have to enter into a table, like that kind of tells me left and up 8. That's my starting spot. And then, you know, you move on a little bit to -5, and then you get to 0. I'm just putting in some numbers. And then I get to 5, and then I get to 7, my endpoint. And those are all my, that gives you a sense of where that graph goes. It also, the table could help you find where your window is. Like when I went times 7, my x is 11 and my y is 6. So if you put those endpoints in there to test out how big the window is, you get a sense of it. So now, if you have a min and max, t min and max, -7 to 7, a step of 0.1, you could probably tell me with tracing when it's in quadrant 1. So go discuss for a minute, and I will find you. Oh yeah, I'll find you. Do you want me to find you with a dart or the random selector? Do you prefer to be impaled or just generally selected? I'll go with Erica's decision. What do you want, Erica? Impaling or general selection? Okay, good call. So you like that noise? So what I'm looking for is, if you get a graph going, when is it in the first quadrant? What times? So I can tell you now it's not -7 because that's the very upper corner. But when does it land in the first quadrant? Like what ones get you there? If you want to look at the table, kind of gives you, and start plugging in numbers and figure stuff out, see like where it hits. So go for it. Figure it out. Y'all are so clever. I'm going to let you have that fun. This will be part 1 of the recording here. I'm going to bust it in half here.